Good morning, everyone. This is Srividya Bansal. I'm sorry for the interruption. Good morning again. This is Srividya Bansal. I am assistant professor at Arizona State University in the Ira A. Fulton Schools of Engineering. Today, I'm going to talk about my project titled Instructional Module Development System. More specifically, I'm going to talk about a repository of instructional and assessment techniques for outcome-based education. So we have this repository built into the IMODS system. And when I refer to the IMODS system, I mean the Instructional Module Development System. So this project is a collaboration with the University of San Diego with Dr. Odesma Dalrymple. It is funded by the National Science Foundation under the Transforming Undergraduate Education in STEM program. So with that introduction, I'll get started. So what is iMod? Basically, it is an open source web-based tool which is still under development. The purpose of this tool is to guide STEM educators, either individual or collaborating, through an outcome-based education process. Basically, the idea is to scaffold instructors through a step-by-step outcomes-based education course design process. So the tool is built using a theoretical model called the PC Cube model that Dr. Dalrymple and myself came up with. And it is based on a number of other existing popular models, like the models by Wiggins and Matee, the backward design. So we drew inspiration from all of them and came up with our own model called the PC Cube, where the PC Cube stands for performance, content, condition, and criteria. So the idea is that in our model, the learning objective is the central is the central component of a course design. And in this model, every learning objective comprises of 4 parts, which are the performance, content, condition, and criteria that you see in this shown in this figure. The performance aspect of learning objective is nothing but what is it that we want the students to basically be able to perform as a result of this objective. So, and that's what's the performance, and it's linked to the Bloom's taxonomy, basically the different learning domains and the levels of learning. So that's where performance is drawn from. Content is basically the topics that we're trying to teach for a particular learning objective. Condition is the conditions under which this learning objective is to be achieved. And criteria is basically how are we going to measure if the student has indeed attained the learning objective or not. So like I mentioned earlier, the learning objective is the central component of course design. And all the other components like content, assessment, and pedagogy, or the instructional technique, they're all connected to the learning objective. So basically, the instructional technique of pedagogy relies on the performance and content parts of the learning objective. So depending on what kind of performance we want from the learning objective and what kind of content is being taught, an appropriate pedagogical technique is to be chosen. The content topics itself rely on the content that we want to teach as part of the learning objective and the conditions under which this learning objective is to be achieved. And then the assessment basically relies on the performance and criteria aspects of the learning objective. And that's what you see in this PC cube model figure over here. So what we're doing is basically we are taking this literature and translating this literature in outcomes-based education into a software tool called the IMOT system. So the goals of the IMOT system are to provide a step-by-step outcome-based education process. It's to basically provide that scaffolding to the users. Also, we want to provide a repository of current best pedagogical and assessment practices. What are the currently, what are the techniques that are being used by the engineering education community and the ones that have been working very well? We want to provide a repository of those for instructors to pick and choose from. We want this tool to generate documentation of course design so that there is evidence of continuous improvement as the course evolves over semesters. We also want it to provide help to the user, just-in-time help as and when it's needed in an easy and simple manner. And most importantly, we want to provide feedback on the fidelity of the course design. What I mean by that is we want to provide feedback on the quality of the course design, how complete is it, if all of the components of the course design align properly or not, as in the different components being pedagogy, assessment, and content, and they have to align well with the learning objectives. So the tool would provide feedback on the course design. So here's a UI screenshot of how the tool looks. It's basically structured into 5 tabs. And what you're seeing here on this screen is the first tab, which is the course overview, basically the overview information. And then the remaining tabs are, the second one is learning objectives, followed by content, followed by assessments, and then pedagogy. The idea is that the users are forced, I shouldn't say forced, they're directed to first fill in the overview information, followed by the learning objectives. And then they can connect those learning objectives with corresponding content, assessments, and pedagogy. So the tool is guiding the instructor through this process. So on the screen, you see basic information about the course is collected. Things like course title, course number, the URL, where is it, oops, sorry, where is it being conducted, the class, the semester. There's an instructor section. There is a schedule section on the right-hand side. There's a section for grading, for different kinds of course policies, which could be things about grading, attendance, late submissions, professional conduct. So the tool provides default policies, policy description for all of these different categories. And then it also provides the option to customize those descriptions. So the instructor can either use the default policies or customize it based on his or her course. Also, you see on the right-hand side, there is an area for quick tips. So that's the place where we will be providing help information related to the tab on which the user currently is. So here's the learning objectives tab, which is the second one. The way the screen is organized is on the left-hand side are all the learning objectives that have already been added. And then what you're seeing in the middle, the center panel is the PC cube. So the UI guides the user to entering those 4 components: the performance, content, condition, and criteria. And they are connected to Blooms, to the different learning domains. And within cognitive learning domain, it will then show the corresponding domain categories, that is basically the levels of learning, whether we want the students to just remember or understand a certain concept, or do we want them to learn at a higher level of apply or further go higher up to evaluate and create new knowledge. So the instructor has to decide on that level of learning at this point. And then we use the thesaurus to show the different action words. So basically we get all the synonyms and related words that fit into the domain category of apply in this case, and they're displayed to the user so that they can pick an action word that is most appropriate for their learning objective. So you see on the left-hand side, a number of learning objectives have already been created, and the top one that just says apply is currently being constructed. And once the user enters all the 4 parts, that is the content, condition, and criteria, then automatically the sentence gets constructed, both in the left panel over here and at the top over here. And any filler words to complete the English sentence can be provided by the user by editing the top, by editing this top section. So you'll see here a number of objectives have been created, things like use modular programming techniques such as functions and objects. So basically, it's the content topics that have been entered. In this case, use is the performance keyword. Well, use is not a good action word. We should not have had that example there. But things like apply a disciplined problem-solving process to the construction of, say, algorithms. So, and then here we cut it out deliberately, but then the complete learning objective gets displayed at the top in this area. So that is to give you an idea of how the different tabs look, but I'm not going to get into too much details of these tabs itself, because the purpose of this presentation is to talk more about the repository of assessment and pedagogical techniques, which are displayed in these last 2 tabs. So I'll talk a little bit about the framework that we use to build the pedagogy component. So we have the IMOTS PCQ model, and we have our learning objectives described in terms of performance, condition, criteria, and content. So you'd see that the performance is basically drawing from Bloom's taxonomy, and that's what we just saw. And then the revised Bloom's taxonomy also has a knowledge dimension to indicate the knowledge dimension of the content. So what I mean by that is there is a way to, the instructor is asked if the content that's being taught, is it of the factual dimension, or is it more procedural, or is it a metacognitive kind of concept? So they have to provide that information as well. And that information is used in looking up for appropriate instructional techniques from our repository. So in the repository, we did an extensive search of literature of all the popular engineering education journals. We looked a little beyond engineering. We looked into STEM, which is science, technology, engineering, and math. We looked into journals that are relevant in those areas, as well as conference publications to build the repository. So broadly, each technique in the repository has a description. It has a list of activities in the technique. It has, if there are some materials required in order to administer the technique in class, then it will list those. It will provide examples and references, basically the origin of where we found that technique from. So, and then there's a few more fields, like the time needed to administer this technique in a class. Is it appropriate for an online class or an in-person class, or maybe a hybrid class? So there's a few more parameters that we keep track of for each technique, and then we display them to the user. So Here's how the pedagogy tab looks. Now on the left-hand side, you see the learning objectives. So we are assuming that the user has already created all of these learning objectives using the second tab that I showed earlier. Now the purpose of this tab is for now, the instructor can pick a learning objective and look for appropriate instructional techniques for that particular learning objective. So in this case, you see the first one is selected, apply the concepts of sequence selection and iteration. So the example that you're seeing here, this is for a introduction to programming course. It's a computer science course, introduction to programming. So for the first objective, so you'll see that at the bottom, the filter options will automatically get selected. This learning objective belongs to the cognitive domain, and it has the action word apply. So the domain category is apply, but then we automatically select everything below the level of apply as well, because if you want a student to be able to apply a concept, we can assume that they remember and understand it, and therefore now they're also able to apply it. So automatically we choose all the lower, whatever the learning level is, we choose that one and all the lower levels as well. And this is the purpose of this is to find ideal matches for instructional techniques. And then we also use the knowledge dimensions, which is basically the knowledge dimension of the concepts that are listed in this learning objective, whether it's a factual concept or a procedural concept. And based on that, we find appropriate techniques. So in this case, you see there's a number of, there's about 7 ideal matches displayed for that first learning objective. And then the instructor, the user, has the option to pick and choose. Everything that's in the green tick mark are the ones that are chosen for this learning objective. So basically, an instructor can choose one or more techniques to teach each learning objective. So in this case, we chose face-to-face video or audio lectures. Well, face-to-face or video or audio lectures. So this is basically the traditional lectures. Then we also chose a partially guided programming exercise so that we could do a hands-on activity in class. There is an active reading and a guided lab exercise. So these are the pedagogical or the instructional techniques that will be used in class. At the top over here, you see the breadcrumbs for basically the filter options for which these matches are shown. It's for the cognitive domain. The domain category, there's 3 selections. When there's 2 or more, up to 2 we display them. Beyond that, we just say that there's 3 selections. And those are apply, understand, and remember, as you can see over here on the left-hand side. The knowledge dimensions are factual and conceptual. So we've seen the ideal matches for those. Below, actually in this picture, it's cut off. We also show extended matches, which is we extend it out further for just the cognitive domain. And we ignore the knowledge dimensions and the domain category filter options, and we show the other available techniques as well, so that the user can look at it and pick and choose from them. Now we also have some other aspects, such as an instructor can favorite a technique, so that's what you see with the star. They can create their own new techniques, or they can kind of customize an existing technique by cloning it, which will basically create a copy, but then they'll have to make some changes to it to customize it. So the user has those options as well. Now clicking on one of these techniques over here will, or clicking on add new, that's here at the top, will basically display a dialogue like this, wherein they can actually key in information about the technique and add it to the repository. So we're still figuring out the details of kind of roles and who is allowed to add new techniques to the repository. So maybe just only administrators could do it, or maybe we have some people who are who have the role of an expert who are allowed to add techniques. So we're still in the process of figuring out those details. But here you will see the different fields that are there for any instructional technique. There's a title, the domain category, knowledge dimension. There's a delivery mode, location, focus. And by focus, what do we mean is it a reading focus activity? Is it a writing focus activity? Is it presentation? Is it programming? So we could have those kind of things in the focus. And then we have a number of the materials required, references, description, etc. A few other things that you see over here. Clicking on favorites will basically display all the techniques that this particular user has favorited. Clicking on instructional plan will kind of generate a report as to what is the plan for every learning objective. The corresponding techniques that have been chosen will get displayed in the form of a report. So this goes into the documentation. So there's a number of ways in which documents are produced. I forgot to mention the syllabus. So on the first, let me go back to course overview. So there is a generate syllabus button, and clicking on that will basically take in the content that has been added on all of these tabs, and it will generate a syllabus. And the syllabus is also customizable by the user. They can choose what they want to appear on the syllabus and what they don't want to, and items can be reordered. Sorry. So basically that's the instruction plan is also part of the documentation of course design. And these are the kind of things that could be handed to a student in the class, to students in the class if needed, and then an instructor can customize them. So similar to the pedagogy framework, we also have an assessments framework, which also relies on the PC Cube model, but this time it more specifically relies on the performance and the criteria aspect of the learning objective. And based on that assessment, appropriate assessment techniques are suggested by the tool. So you'll see, again, an assessment technique has fields like type. So we want to say whether it's a formative assessment or a summative assessment. We have description, procedure, some examples. There's a feedback mechanism. How is feedback provided to the students? There's an evaluation, duration, and then when is it carried out? What is the implementation difficulty? How much time is needed? So duration is basically how much time is needed to do this in class. Those are the kind of things that we are keeping track of. Now, I should talk a little about criteria. So in the learning objective, I said that we want to clearly specify what is the criteria for measuring whether the student has achieved the learning objective or not. So the different types of criteria, the criteria can be categorized into 4 types. Do we want to measure it as speed or accuracy or quantity or quality? So in the learning objective, these criteria can be specified, and then they are used in finding an appropriate assessment technique. So here's how the assessment tab looks. It's very similar to pedagogy. The difference is, again, so we're using a learning objective is selected, and based on its performance and criteria, these filter options are automatically pre-selected, and then the ideal matches are displayed according to the performance and the criteria that have been chosen. And then there's an extended matches section below, which will show the remaining techniques. This tab also has the option to favorite assessment techniques. There's an assessment plan, which will again generate a report of all the learning objectives and their corresponding assessments that have been chosen. The user can clone a technique or add new techniques over here as well. So that's a brief description of how we use the repository in the tool. Now for the data collections, so far we have about I want to say about 40 to 45 techniques for assessments, and and about the same number for pedagogy. So what we did is we collaborated with our librarian to do the searches and to come up with search strategies in order to find these different techniques and populate our repository. So far, we looked at the following places in populating the repository. We looked at the American Society for Civil Engineers, the American Society for Mechanical Engineers, American Society for Engineering Education, ASWE. We looked at IEEE Digital Explorer and ACM Digital Library because those are the places where most computing, computer science, software engineering related public CS education or software engineering education related publications are. In addition to that, we also looked at some popular textbooks in the education field. Collaborative learning techniques was one of them. Student engagement techniques is the second one, again by the same author, Elizabeth Barkley. So these two books basically had a number of pedagogical techniques, instructional techniques, and we pulled a number of our techniques from here. There's also classroom assessment techniques by Thomas Angelo and Patricia Cross. This book has about 50 assessment techniques, and we pulled a lot of hours from here. Now, some of them there's commonalities between what we found in the journal articles and in the books. So in those cases, we entered them as one entry into the repository and provided references to both the journal articles as well as the book chapters. So this is what we've done so far. There is more to do. We realize that this data collection process is not that simple. It turned out to be a pretty complex task because especially with the journal articles and conference proceedings, the papers have to be read through and interpreted, and the information needs to be distilled and pulled out. It is quite a challenge, and that's the reason we had to, and even coming up with search strategies is quite a challenge. And that's the reason we had to collaborate with our librarian for that. So here are some examples of the techniques that we have in our repository so far. For instructional techniques, we have things like partially guided programming exercise, structured problem solving, think aloud protocol, paired problem solving, paired programming. Number of them, and you might be familiar with a number of these. You might have seen them before, or maybe not. Things like in-class portfolios make sense for engineering, critical debates, three-step interviews, roundtable discussions. So these are some of the instructional techniques. For assessment techniques, we included formative and summative techniques. So for formative, things like background knowledge probe, pro and con grid, minute paper, Medius point, jigsaw, learning activity. For the summative techniques, we added things like final exams, capstone projects, which is basically like the final year projects, the equivalent of final year projects, practicum or internship, midterm tests, final projects, presentations, senior recital, which is again like a final year recitation. So those are some of the assessment techniques and pedagogy techniques that we have in the repository. So this tool is the first version is almost ready. We are doing we are testing it, and we are doing a round of usability testing with it right now, and then we plan to open it up for everyone to use, and then we will continue to populate the repository with more techniques and even come up with a process of soliciting new techniques from our users and adding them to the repository. To start with, we cannot allow just the entire user base to allow to add to the repository. We need some kind of a monitoring or some kind of an advisory board or an approval process before a technique gets added to the repository. So we are in the process of figuring that out right now. So the project website is available at imod.poly.asu.edu, and my contact information is here, srividya.bansal@asu.edu. On the website, you will see there are a number of our publications, the reports that that we have so far, posters, and we're also we're building our videos as well, a collection of videos to explain the usage of the tool. So we're posting all of those on the website. So you can feel free to browse there and contact me if you have any questions or if you are interested in using or trying out the tool. Or if you are interested in even participating in our usability testing, that will be of great help. So I'll stop at that and I'll open it up for questions. Let me see if there are any questions so far. I don't see any yet.
We request the attendees to type in any questions they may have. So there are a couple of questions. How are the pedagogies listed or updated in this tool?
So the question is, how are the pedagogy techniques listed or updated in the tool? So by listed, I'm assuming you mean how did they get entered into the repository? So we are doing it manually through the data collection process that I described. And so far we have about 45 pedagogy techniques. So it is a manual process right now. Now the tool will allow addition of new techniques, but we are allowing new techniques to be added only by administrators so far, because like I mentioned, we will need a process to monitor that and allow only valid pedagogy techniques to get entered into the repository. It's also a little complicated because each technique needs to be marked with the appropriate categories. What is the technique applicable for? Is it applicable for cognitive domain or affective domain or psychomotor domain? What kind of domain categories is it applicable for? What kind of knowledge dimensions is it applicable for? So some of those the categorization needs to be done correctly, or rather someone needs to review that, and we plan to have some kind of an advisory board that will take in these new techniques that are coming in from the users and review them and then add them to the repository. So I hope that answers the question.
Is this tool free?
The tool is free. The plan, yeah, so far it is free. We haven't opened it to the public yet, but the plan is to open it up and make it free. Later on, we are also considering commercialization, but then if we do end up doing that, there will be a free version and then maybe a commercial version for more larger enterprise or university level. So it is still in the very initial phases. So at the moment, it will be made free. Also, on that note, if any of you are interested in trying out the tool, please send an email to me. so that I can get in touch with you one-on-one and discuss some of the different options and how you can participate on the project. And maybe we could collaborate on the usability testing aspects and even collaborate on publishing those results. So I am very interested in exploring those kind of opportunities if any of you are interested. And I'm assuming most of the attendees are instructors and they're instructors in engineering. So this and if your school, college, or university follows an outcomes-based education process, then this would be something that's very useful.
What is the importance of pedagogy framework?
The pedagogy framework, the reason I showed that is to show how our underlying model is. So the techniques, it's basically a search. We almost have the search functionality built into the system. So we have the repository of techniques, but then we want to suggest to the instructor who is designing a course, we want to suggest appropriate techniques. So the pedagogy framework, the purpose of showing that was to show how that selection is being made and how we are determining whether a technique is appropriate for a learning objective or not. And the way we're determining that is using the performance and the knowledge dimension of the learning objective. So that's the reason I showed the pedagogy framework.
Those were all the questions. Thank you very much, Professor Bansal.
Okay, thank you. Thank you so much for listening. And like I said, the website is imod.poly.asu.edu and my email address is available here. Please feel free to contact me if you have any other questions or are interested in getting involved in the project.
Thank you.
All right, thank you. Have a good day.
You too, ma'am.